All right, so this week I'm going to use the slides that come with the textbook, and so I might scroll through a few of them a little bit quickly, but you have access to these slides in your lectures and notes. So of course, like any other programming language, Java provides many useful methods for us to do some common mathematical functions. And they include these in what's called the math class. So we're learning Java, and we learned that capital letters mean something. Capital letter in Java means a class name. So when we see the math class, we know that's a class that contains lots of useful functions we can use. Okay? In Java, they're called methods. If you want to look up any type of class online, this is normally how people figure out about classes in the real world. Java has thousands of classes, right? Like probably like 100,000 different libraries or different classes you can use in Java. And so many people do not memorize these classes. So when you want to figure out about a class, let's say the math class, you go online and you look up something called the API. API stands for Application Programming Interface. Okay? Or Application Programmer Interface. And it's pretty much the directions to use a programming language is its API. Okay? So when I type in Java API Math, or Java API and then the class name, whatever class it is, here's string and random, scanner, number, those are other classes people have looked up. Usually the first link that it gives me will be to the docs.oracle.com. And that's where the API, the standard API resides, is on these servers. And when you look up a class in the Java API, it looks like this. And at first it might seem a little cryptic and you might not be able to understand a ton of stuff in here. But the more you look at it, the easier it gets to read and the more you'll understand. And if you are a computer science major, you have to start looking at these APIs, because this is kind of like your directions for using a programming language. C++ has APIs, Python has an API, any kind of programming language has an API you can look up online. Okay? And so this is for our class math. And so in your textbook, he goes over a few of the functions that the math library has, or math class has. Okay. But for all of the functions it has, come to this API and you can see that it has lots and lots more functions than the ones that they list in the textbook. Okay. So these are all the methods that you have access to. And in Eclipse, when we do our shortcut menu, we can see all these methods as well. But it's good to know that this is here, and how to look something like a class up using the internet. So some of the things the math class has that he points out in our textbook is it has these things called constants. And constants means that it's a variable that holds a value that you're not allowed to change ever. That's what a constant is. It's a variable where you can't change the information inside of the cup. And so there's a constant for pi, which makes sense, 3.14159, yada, yada, yada. Now, do you think we can store all of pi inside of our computer?
Yeah.
Pi is an infinite number. Can you store an infinite number in your computer? No. So this is an approximation to pi. So remember, your calculations will be slightly off because this is an approximation. And then it also has our E. It has methods for trigonometric methods, exponent methods, rounding methods, max, min, absolute value, and random methods. Okay, these are the most used methods, the max, min, absolute value, and random method. Now looking at this API, let's look at some trigonometric functions really. Let me scroll down to sign. So he starts out looking at some trigonometric functions. I think it's almost more useful to go to the API here. And notice that we have a function called sine. This is called your method header, and this tells you everything you need to know to use this function. So when you use a function, you have to know the name of the function. So the name of our function is sine. And you have to know what to put into the parentheses. Every function is going to have parentheses, right? Some of them you don't have to put anything in the parentheses. Some of them you have to put one thing in the parentheses. And some of them you have to put two things in the parentheses. 3 things, 4 things. Okay, these are called your, when I define my function, they're called a parameter. So this is called a parameter. But when I use my function, like here I'm using my function, this is called an argument. So when I'm defining my function, this is a parameter, so that's telling me, hey, I have to send it a double value in the parentheses in order for this function to work. So when I call this function, I send to it an argument of type double. And the argument of type double takes the place or is copied to the parameter. And so, in other words, if it says you need something in the parentheses, you put something in the parentheses. And I bet you could figure out what math.sine is going to do to that number in the parentheses. What is it going to do? It's going to take the sign of that number and it'll give you back or return to you the answer of sine of that number. So sine of 0 returns 0. Sine of math.pi, so sine of pi divided by 6 gives you what? You guys remember your trigonometry?
Square root of 3 over 2.
It gives you back 0.5, 1/2.
Oh, I said the other one.
That's good though. We're recalling our trigonometric functions. If we do pi over 2, pi divided by 2, it returns a 1 to us. I'm assuming this is correct. Sine of pi divided by 2 gives you back a 1. Okay. And I see some nodding, so I'm thinking we're right. Okay, if I do cosine of 0, it returns a 1. Cosine of pi divided by 6 returns 0.866. And cosine of pi divided by 2 returns 0. Now I just said you had to put one thing in the parentheses, and this is not putting one thing in the parentheses. But note that if you put an equation in the parentheses, like pi divided by 2, it calculates that first. That returns a double, and that double is sent to the cosine function. Because we still do our order of operations, PEM does. We still do this calculation in the parentheses first and then call our function. With that little bit of knowledge, you can use all of these functions in your math library. So if you need to find the square root of something, use your square root function. If you need to find a power, like something raised to a certain power, guess what? There is a power function in here. Here it is, pow. It's usually named pow in lots of programming languages. Note that the power function has 2 things in the parentheses. And the first thing is your base, and then the second one is your exponent. So you would give it 2 arguments when you call this function. In fact, so if I wanted to find like a random number, let's say I wanted to use this class called random. It's part of my math library. It tells me what it does. It returns a double value with a positive sign greater than or equal to 0 and less than 1. Okay, so it's going to give us a number between 0 and 1. And just so you see the worth in using random, we use random all the time. And when do we use random all the time? All the time. Artificial intelligence and in our games. Have you ever tried to play a game that didn't use dice and didn't use cards and didn't use anything random? Actually, I went to a game development conference and they had us play this game with no dice, no cards. And what happens when you play a game like that? It has no randomness.
It's no fun.
Yeah, the same thing keeps happening again and again and again. You keep playing it the same way because there's nothing random to kind of change it up. Every game that you play on your computer has to use some kind of randomness. Otherwise, it's very boring. Okay? So we use random a lot. Okay? You use random in programming. So it's worth it to figure out how this random works. Because all programming languages have a random method or function. And most of them have a random method that works very similar to the Java random function in this math library. Okay? To learn functions, let's just look at that random. So you guys could follow along with me, or you could just watch. You could watch this one. Okay, so if I wanted to use math.random, if I want to use any of those functions in the math library, they're all static functions, which means I can just use the class name to call this function. When they have this word static here, that means I can just use the class name to call the function. So I just put my class name, which is math. I put a dot operator, and there's all my functions. And if I start typing random, there's my random function. And just to show you that it did give me a number between 0 and 1, I'll go ahead and print them out. Now, why do you think it's red underlined? I know why it's red underlined, but why do you think he's red underlined? Yes. Okay. I'm trying to store a double inside of an integer. And how did I know he was sending me a double? Well, he's sending me a number between 0 and 1, for 1. And 2, right here, it tells me that it's sending me back a double. This is your return type. It's telling you what it's giving to you, what it's returning to you. Okay, so once I make it a double, then it can store that double number, and I can show you when I run this code that it does give me a very big number. Well, actually, sorry, a very small number, between 0 and 1. It just has a lot of digits. Okay. Now, what if I wanted a number between 0 and 10? Huh? We could do some stuff like that. But a common thing to do is just manipulate this number in some way. What if I multiply this number by 10? Now, if I multiply any decimal number by 10, what does that do? It moves the decimal place over 1. So what if I multiplied it by 10 and then I got rid of all the decimals? So I move the decimal place over 1 so that I have 1 digit on the left of the decimal place. And then I got rid of all the rest of the decimals. How do you think I get rid of all the rest of the decimals? There's some different ways that you can do it, but one way that you can do it is you can just force this guy to be an integer by typecasting it. This is called a typecast. I'm taking this double number and I'm converting him or changing him to an integer. So in other words, he's going to lop off all the decimal places for me. So the multiplication by 10 moves the decimal place over once. And then changing it to an integer gets rid of all the rest of the decimals. So if you run him again, and you run him multiple times, he should give you different digits between 0 and 9. Keep getting 0.
Yeah.
Make sure that you have these parentheses around math.random too. If I forgot these parentheses, what it does is it changed my decimal to an int and then multiplies that 0 times 10.
Oh.
So you had to have both parentheses. You had to multiply them by 10 first. So you move the decimal place over 1 first and then convert it to an integer. And that's actually a very helpful thing to do. Let's say I wanted a number between 10 and 20. What am I going to do?
Random put 10.
What if I just added 10 here? If I get a number between 0 and 9, and I add 10 to it, now I have a number between 10 and 20. You see how this will be my range, and this is my offset, how much I'm offsetting from the timeline. And that'll actually give me a number between 10 and 20 each time. And it should give you different numbers each time. Actually, 10 and 19. Sorry, 10 and 19. If I wanted 20, I would have to put 11 here, right? All right, so we see the importance of these functions. Hopefully we realize how they work, especially static functions. You put the class name, the dot operator, the function name. You always have to put parentheses, even if there's nothing in them. And if they do require a parameter, you have to give it an argument. Okay. So last but not least, let's make sure we understand that part too. So like if we had something like the POW function that requires 2 parameters, then we would have to give it both arguments. And it does return a double, so we do have to give it a double. So that would be 5 to the power of 7. All right. So we understand our functions, right? Now here's a couple more functions that he went over in the book that are useful to know that they exist, because we do use them in programs sometimes and they're helpful. We have something called the ceiling function. It's called CEIL. They abbreviated it CEIL, but it stands for ceiling. And what it does, here I won't even tell you what it does. See if you can guess what it does. And I'll give it a value of 5.9. What do you think ceiling is going to return to me? Yeah, return 6. Now what if I gave it the value of 5.1? Gives me 6. So do you see what the ceiling function does? It rounds, but it always rounds up. It takes it to the ceiling. That's why it's called the ceiling function. Okay, it was around before Java. C actually has the ceil function, the same one. Okay, so you know how ceiling works? It always just rounds up, no matter what. How about floor function?
Rounds down.
Yes, exactly. It takes you to the floor and it rounds down. Okay, so if I were to run this function, you can see it rounds down. Even if it was 5.9, it'll still give me 5 because it rounds down. At first you might think, oh, I'll never use these, but they actually do come in handy in a lot of programming problems. Okay. RINT stands for round to the nearest integer. Okay. So that one's how we round. And then round takes in a float. And he shows you this cool trick. This is how we used to round numbers before the round function. You add 0.5 to a number, then you floor it, and you convert it back to an integer. And does that make sense to you? Like if you had 4.5 and you added 0.5, it would be 5. You floor it, it's still 5, and you turn it into an integer. Do you see how you can use the floor function to round something? All right, I'll let you look at that. All right, he gives us this whole kind of, you guys can look at this on your own, but, you know, calling the different methods. I bet you can guess what max does. A lot of these methods, you should be able to know what they do just by their name. Okay, max and min work the same way. You give it 2 arguments, and it returns the higher of the 2 for max. And it returns the lower of the two for min. That's pretty easy, right? And then the abs function does not make your abs into abs. Abs of steel. No, it stands for absolute. It just gives you the absolute value. Okay? Now he actually goes into the random function, but I already did this in class, so I'm going to kind of just gloss over this. But he gives you some more examples of using random in the slides. And he gives you some examples of using some trigonometric functions. And I encourage you guys to run this code at home, especially if you're interested in math. You guys can copy and paste some of this code and try it out. All right, and he goes into character data, and he actually goes into character data a lot inside of the text. And in some of your earlier labs in here, in your variables labs, I had you look at character data. And you guys saw how the character data was an integer in your computer, stored as an integer in your computer, and translated back to a character. Okay, so just kind of a reminder of what character data is. Here's our ASCII chart. He brings up the ASCII table. But remember that you can go online and look up your ASCII table. And just remember that your characters are stored as numbers in your computer, and they can be translated from number to character. Such as, if I had a character, and let's say I set it equal to the letter A. Note that characters are not strings, and we only use a single apostrophe for a character. And then I take that letter, and let's say I typecast it to an integer. Or I'd say, okay, int. Notice I get no kind of red error. It lets me store that letter A as an integer. What should print up right here? Of course, this one's going to print out the letter A. But in my second system out print line, and I stored this letter A as an integer, what will print out to the screen? Yeah, it's ASCII value of 97. This has lots of implications inside of our programming language. We can use this fact inside of our Java statements. I can say, is that letter? I can see that if it's a letter, if it's greater than 97, greater than or equal to 97, or less than or equal to 122, I know it's a letter. Or I can see if it's the letter A by checking to see if that letter equals 97. Okay. So I can use the equals operator, and I'm checking the equality of a character, a char value, to an integer. So you can use the fact that your characters are integers and do things like that. Use the equals, greater than, less than operators. And that comes in really handy too in a lot of programs. Okay, and you can see that, hey, that came out as true, so that was a true statement. All right. I'm going to kind of just glance through some of these and get to our strings. All right, so the string type. Strings in Java, we used strings on the first day when we wrote our hello world message. So anything in between quotation marks is a string. A string is made up of characters, but it's considered a single object called a string. Okay. There are string methods that we can use. Okay. Some of these methods we use all the time, like length, returns the number of characters in our string. Character at returns the character at the specified index from the string. Okay. Uppercase makes it all uppercase, lowercase makes it all lowercase, and trims our string. So I think it's better shown with actual code. So I'm going to show you how it works just by demoing it here. So let's say I make a string. And I'll say hello and welcome. And we'll call up some of his methods. So remember that if you wanted to call methods of a certain object, like a string, you write down the string's name. I named my string S. And then I use the dot operator, and there's all of those methods that he was talking about in your textbook and in the slides. We'll start out with the length method. I know this string's a little long, so let me condense it. What should length print out? What will it print out for my length? Good, I see the number 5, yes. Because hello is 1, 2, 3, 4, 5 letters long. It'll give me back that my string is 5 letters long, or length 5. How about if I use the character at method? So the char at method returns a character. And I have this number in here. And I'll run him, and I bet you can tell how he's going to work. Now he returned the L. Now is he returning this L or this L? Do you guys know? You guys remember reading that in your book? And actually he does return the second L. And the reason is when you're counting characters in a computer or an array of characters, you start out with the number 0. So he's actually at index 0. He's at index 1. L is at index 2. And this L is index 3. And this O is at index 4. And to show you that, you can print out index 0. It'll print my capital H. If I print index 4, it'll print out my O. And what if I print out index 5? I bet you guys could guess what's going to happen. What do you think is going to happen? It's going to try to index over here, but there's nothing over there. And yes, we get a runtime error, and it's an index out of bounds error. Okay. That means, hey, we tried to index something that wasn't there. This character at method is really helpful. And we'll use him a lot in our class. All right. How about to uppercase? Let's look at that one. What happens when I do something to uppercase? What do you think it's going to return to me? Right, the same word, but everything's in uppercase. And how about to lowercase? Of course, it's going to make it all lowercase. And what you have to remember here, though, when you're using the to uppercase and to lowercase, is that it's returning to you a new string. It's not actually changing your string. So if I were to print out this string right now again, it's going to print my lowercase string. I mean, with the uppercase letter in it, because I did to lower. What if I wanted to change this string permanently to all lowercase? Then you have to set it equal to what this function returns. So this function returns a lowercase string, and you have to put that lowercase string back into S if you want to transform S to all lowercase. So note that that function returns a lowercase string and doesn't actually transform your string, so you have to put it back into that string variable. All right. And with that, you should be okay with string methods. Of course, are there other string methods in the API? Of course. There's more than what your book tells you. If I look up the API for Java on strings, you can see that it has actually a lot more methods than the ones that it's telling you, because string is used so very much. So your kind of rule of thumb is if you're doing anything with strings, there's probably a method to help you do it. So just remember that. You don't have to memorize all these methods, but know how to come here and look for a method that's going to help you solve that problem. Or, even better, go into Eclipse and look for a method. If you hover over these methods, they should, your home computer should bring up the little shortcut and tell you about that method. But, remember that if you're doing anything with strings, there's a method to help you. All right, and he just goes into talking, saying, hey, these are not static methods, so we don't use the class name to call it. We use the actual string name to call it. So remember, you use the actual S or the object to call the method, because these are not static methods. They work upon the string. Okay. And we went through this. Now this is one thing I do have in my lab, and we kind of went over already, but it's good to see this picture and visualize what a string is inside of your computer. A lot of times when we describe strings, we'll draw a picture that looks like this, and this looks like an array. And this has to do with their indices. So when I say index 9, I'm talking about this index right here, and that letter O is at index 9 in this string. And of course, we start at index 0. He talks about string concatenation. Now we've been doing this kind of all along inside of our system out print line statements. Meaning that when we wanted to put two strings together in our output, we wrote something like the string is, and then we use that little plus sign there. So now in this slide, in this chapter, he goes over what that plus sign actually is. It's called a concatenation operator. And what it does is it just glues all of your strings together. If we had a number on this side of the string, it converts that number to a string and glues it onto the string for us. So that's called your concatenation operator. You don't have to use your concatenation operator just inside of a system out print line. You can use your concatenation operator up here. In fact, an easy way to convert a number, so let's say I had a variable called number, and I now want to output it to, let's say, a text box on my web page. If I want to output a number to a text box, I have to send it as a string. An easy way to convert a number or any kind of object to a string is to concatenate it with an empty string. So you take an empty string, you glue on the number, and voila, you got a string. So remember that trick. Okay, whenever you want to convert a number to a string, just concatenate it onto an empty string. So that, in a nutshell, is strings and mathematical functions.